Hey guys, this is Nick Abrahamian, or Marek Abrahamian. This is a commercial application EL150. All right, Unit 4, Day 1. We're going over objectives of laying out and wiring a basic room and a commercial environment using knowledge from previous labs. Previous labs including both numerous our residential mod or solar mod. Well, actually we're just coming from a residential mod, so we laid out receptacles using, again, non-metallic conductors like Romex 14.2, 14.3 in wooden base. Okay, and this objective, it tells us, actually in our equipment, it tells us recessed lighting and commercial bay, okay, in the lab equipment. So actually we're moving over and transitioning to commercial application. Okay, before I get to that side, I want to distinguish the difference between the material that is required. Okay, the material that is accepted on commercial jobs is a completely different standard than single family dwellings or multi-family dwellings with residential bays or studs. Okay, we're allowed to run MC, for example, on the residential side. Okay, but on the commercial side, Romex is not allowed. Hence, we're moving over to the transition of using MC, running conduit, setting up lightings, circuits, and laying out a basic room. This first lab is an introduction, okay, to installing a switch box, running a dedicated home circuit or home run, excuse me, and installing a recessed can, just like they did in there for 140 residential mods. Okay, so again, I'm not going to go over all the materials required. You do need 14.2 and 14.3 MC. Okay, safety equipment, hard hat, glasses, all that as well. Right here. Okay. Well, you need a tape measure, flat, a Robinson, strippers, cutters, MC cutter. You also need electrical tape. You're gonna need ground screws. You're gonna need red devils. Okay, also red bushing. Let's get over to this side, to the base. Now, first of all, you are working now with your students in the commercial advanced mod. Okay, I want to emphasize that you have to be super careful when you are setting up galvanized junction boxes. Okay, right before setting up our mod, we just actually had a shortage because one of the wires got stuck in between the covers. Okay, if that was a student there and it got energized, okay, that would be an issue. Okay, number one. Number two, you have to be extra careful when you are working with MC. Okay, a little bit of it gets exposed, it will start to short. All right, first of all metal boxes, all right, must be properly grounded. We have our ground screw here. Okay, our neutrals are also tucked in, it's grounded. All right, that aside, my switch is taped off. Okay, the switch has to be taped. Sorry for the sloppy taping there, guys. All right, but again, go down there real quick. This is extra receptacles that we ran. Okay, you have to also let your students know that we're gonna have a 1/2-inch gypsum board here, and you're gonna have an extra cover, a typical white single plate cover afterwards that you install. That's the reason for mud flaps there. Okay, now panel's nice and made up here. Okay, I have to also explain to my students, again, I don't want to go too detailed into this, but typically for lighting circuits, okay, for office spaces such as this one, okay, we would run circuits that share neutral. Okay, so you would have circuit 1 and 3 for lighting or for power, and it may share a neutral, and you would have a junction box set up for your dedicated home run prior to you hitting that office space. Okay, and from there the power will distribute. Now your home runs, now your also in the three-phase panel. So you have to tell your students when you have a junction box up there, that circuit 7 and 9 for this office's recess lighting, okay, they also have to know which colors 7 and 9 are going to be, okay, because this is a three-phase panel that we're running power off of, okay. So black, red, blue, black, red, blue, black, red, blue. Okay, so black and blue would be circuit 7 and 9. All right, and those will be sharing a neutral. Coming back here. Okay, so first of all, prior to energizing, make sure that all the students are stepping away. Okay, you're properly wearing gloves, insulated gloves, which I'm not right now. Okay, but you have to be wearing gloves while you're testing. Okay, you need to make sure that the breaker at the sub panel prior to energizing here is off. Then you turn it on. Once everything is strapped properly, the MC 6 to 12 inches within the box is strapped. As you can see right there, it's been strapped, and we ran it through and landed into our receptacles here for our for our duplex receptacles. Here we did not have room to actually strap, okay, so it should have been strapped prior to landing, and it got squeezed a little bit. Okay, so you want to make sure to tell your students not to squeeze this shielding, okay, because this can cause a shortage. All right, and there has to be a red bushing inside of it. Okay, this is a part that is very important. Okay, the red bushing is an insulation. All right, when you're working on the other side with residential, with wooden base, okay, you're dealing with plastic, non-metallic boxes where being insulated, properly taped off is not as important. Okay, that aside, let me energize this. Okay, now energized. All right, I would typically check the voltage for my students. All right now, let me see what I got. Okay, the circuit I'm about to test.
It's open.
Oh, breaker's off. Excuse me. Breaker's on, so 120. All right, let me check my other breaker. No shortage. Okay. Can we check that? 120. Next breaker, turning it on. Okay. One of my leads is on the ground bus bar. All right, I'm checking it. What am I getting? 120. Okay, now check the neutrals as well. What am I getting? 120. Second neutral, 120. 120. Okay, if you have a voltage drop, all right, it may be due to a loose neutral, okay, a loose connection somewhere. Now my lights are already on, okay, so I will turn them off right there. There's two fixtures I already have set up, okay, but here is my recess can, which again, you as the instructor, if you want to put a dimmer, that's fine. It's a single pole switch. All right, and up there, you also have to provide slack the same way when you're daisy chaining recess cans in your residential labs. Okay, there has to be slack provided, and that's pretty much it on this lab. All right, let me see one other note I can add on. No, that is it.